So for 18, here's a program that prints the volume of a solid, public class solid main, public static void print volume solid s, system.println, volume equals s.volume, and then cubic units. So in the main, solid equals new sphere. So here you're instantiating an abstract class again, and you can't do that. So I believe that uh, hmm. Yeah, so huh. Perhaps I typed it wrong. Let's see. So you actually shouldn't be able to construct this because sphere can't be constructed. Oh, it's a sphere, not a blob. My bad. So this line is actually fine. You're just constructing a sphere, rec, and you're constructing it, and then you flip a coin, and then a random, which is 0 or 1 by default, and then times 2. So yeah, it just, well, math.random is between 0 and 1, so it's just a double between there, and then you multiply by 2, and it's integer. So it's either 0 or 1. And if flip coin equals 0, else, so you do sphere or rec. So print volume, it calls print volume, and it's called on the solid, and then s.volume is called. The cast is implied, so it's just s.volume, and you end up fine. So A is correct. So for 19, consider the computable interface below for performing simple calculator operations. Public interface computable. Return this object plus y. Object add object y. Return this object minus y. Object subtract object y. Return this object times y. And that's multiply object y. Which of the following is the least suitable class for implementing computable? So large integer, fraction, irrational number, length, and bank account. So you would never have any use for multiplying a bank account or adding a bank account. Well, I suppose adding, but multiplying would never come into play. So E is the correct answer. For 20, refer to the player interface shown below for questions 18 through 21. Public interface player, int getMove, and void update display. So a class human player implements the player interface. Another class smart player is a subclass of human player. Which statement is false? Smart player automatically implements the player interface. B, human player must contain implementations of both the update display and getMove methods. C, it is not possible to declare a reference of type player. And D, the smart player class can override the methods update display and getMove of the human player class. A method in the client program can have player as a parameter type. So all of these are right. You can declare a new object of reference player. So this word is really important, reference, because otherwise it would be asking whether you could construct a player, and you can't because it's an interface. So C is the correct answer because references of type player are fine. It's constructions that aren't. So for 21, a programmer plans to write programs that simulate various games. In each case, he will have several classes, each representing a different kind of competitor in the game, such as expert player, computer player, reckless player, and so on. It may or may not be suitable for these classes to implement the player interface, depending on the particular game being simulated. In the games described below, which is the least suitable for having a competitor class, implement the given player interface. So we have a high-low guessing game, chips, chess, tic-tac-toe, and battleships. So C, because it's hard to number 8 by 8 squares as 1 through 64, you'd want to do a two-dimensional array for chess, but you can't exactly do that easily with these players. So for 22, consider these declarations for questions 20 and 21. Public class human player implements player, private string my name, so it has a new variable. Public string get name. So public class expert player implements player also. Private int my rating. Public int compared to object object. So which code segment in a client program will cause an error? Player P1 equals new human player. Player P2 equals new expert player. And you call get move on both of them. So both of those are fine. Well, this one, let's see. Yeah, so for this one, the get move and update display are not shown. In this one, constructors are not shown. And I wonder if get move and update display are also not shown. So we're on number 22. Yeah, these both work fine because the get move is just implemented in here, but they don't say. So number 2, int x comparable C1 equals new expert player. Expert player does not implement the comparable class, so you can't have a reference comparable. So 2 is errorful. 3, int x human player h1 equals new human player. Human player h2 equals new human player. If h1.compare to h2 is less than 0, x equals h1.getMove. And your problem is right here that human player is not a comparable. Human player doesn't implement the comparable interface. So it doesn't have a compare to method, and it's not right. So 2 and 3 only cause errors. So C is the correct answer.